Hello everyone, welcome back to our YouTube channel. In this video, we are going to see the differential amplifier. Now I am drawing the circuit of the difference amplifier. R1 and R2 are the resistors, and from here one goes to the inverting terminal of the op-amp, and another goes to the non-inverting terminal of the op-amp, and these two are the resistors R3 and R4. And from here we get the output, and we are giving V in 1 and V in 2 as the input voltage for this difference amplifier circuit. This is the complete circuit of difference amplifier. The output V out depends on the function, I can say it's a function of input voltages as well as the resistance value which we are giving to this resistors. We can analyze this circuit and find V out value by using Ohm's law, Kirchhoff's law, and also the voltage divider rule can be applied. Let us analyze the circuit. We can use superposition principle as two voltage sources are involved in this V in 1 and V in 2, which can be separately analyzed by considering one voltage's input at each time. Let me redraw the circuit. By considering the single voltage sources, I am grounding one of the voltage input, that is grounding V in 1. I am redrawing the circuit. Only V in 2 is given now, R3 and R2, here R1 and R2. This goes to the non-inverting terminal. So this is the circuit. Here we can see only V in 2 is given, and here we need to apply the voltage divider rule across the R3 and R4 resistors. This act as a non-inverting op-amp. Just we have to apply the voltage divider rule over here. That's the only difference. The output equation for the non-inverting terminal operational amplifier is V out when input 2 is given is this V plus I'll consider into 1 plus R2 divided by R1. This V plus can be obtained by voltage divider rule across this R3 and R4. That is V out when input 2 is given is equal to V plus is nothing but V in 2 into R4 divided by R3 plus R4 into 1 plus R2 divided by R1. This is the equation when only one, that is V in 2 is considered. Now the voltage source V in 1 should be considered, and I am redrawing the circuit as referring my previous circuit. Now I am grounding V in 2 and redrawing the circuit. And here R3 and R4, this will be grounded. Now what happens is this R3 and R4 won't have any effect, that is this terminal can be directly grounded, and now I am redrawing the circuit by directly grounding that terminal. That is only V in 1 is being acted, and now this circuit is nothing but the inverting op-amp can directly ground this non-inverting terminal. Now it acts as inverting operational amplifier. Now the equation will be equal to simply V out when input 2 is given is nothing but minus of V in 1 into R2 by R1. Now these two equations must be combined using superposition principle, we have total V out will be equal to V out considering input 1 plus V out considering input 2, that is voltage source 1 and voltage source 2. Combining these two expressions, we get the value of V out expression as V into R4 divided by R3 plus R4 into 1 plus R2 by R1, this minus V in 1 into R2 by R1. This is the final expression for our difference amplifier. Now let us take the condition if all the resistors values are same, that is I will consider now at R, substituting all these resistors as R. What we get, we have to just substitute the R in this equation. We get simply as V out will be equal to V in 2 minus V in 1. Now let us consider one more case, that is what if R1 is equal to R3 and R2 is equal to R4 and R1 equal to R3. These two resistors are considered same and these two resistors value are considered same. Now substituting this in this equation, we get V out as R2 divided by R1 into V into minus V in 1. Only difference is in this equation we can see some gain being multiplied to the previous equations. So this is about the difference amplifier for different cases. So thank you for watching. For more such videos, do subscribe to our channel. Thank you.